This message is brought to you by donotage.org, the longevity research organisation that's on a mission to extend healthspan for as many people as possible via products that actually work. Start your journey today at donotage.org and use code LLAMA for a 10% discount. That's LLAMA.
It's about the education, and that's going to be such a major part moving forward within the longevity community, to make sure that we educate and really talk a lot about what's going on with the science and how it can benefit people.
Hello again and welcome to the Live Long and Master Aging podcast. I'm Peter Bowes. This is where we explore the science and stories behind human longevity. This episode is brought to you by AgeUp, a new financial product that provides guaranteed supplemental income for people who worry about the financial impact of longevity. To find out more, visit age-up.com. That's age-up.com. In this episode, we're going to dig deep into longevity science, the science of rejuvenation of the human body, to be precise, and return to the topic of NAD, a molecule found in cells that regulates aging. In recent years, we've become increasingly aware of its importance as we grow older. I'm joined by Dr. Nichola Conlon. She's a molecular biologist from northeast England. I think it's the first time that we've had someone on the podcast from my neck of the woods, which is very nice. I was born in County Durham. Nichola studied molecular biology at Newcastle University, one of the great centres for longevity research, and has since gone on to form her own company, developing products that stimulate the body to repair itself. Nichola, welcome to the Live Long and Master Aging podcast.
Hi, Peter. It's lovely to be here. Thank you.
Great to talk to you. How is the northeast today? I'm sitting here and looking out the window and it's California sunshine. I imagine it's late in the afternoon for you, so I guess it's dark and, dare I say, maybe the weather's a little miserable.
Yeah, it's very dark and it's quite cold now, and definitely not what you'll be looking outside to, I'm afraid.
Yeah, as I say, a tinge of guilt there, but I remember those days, and my family still lives in northeast England, so I visit obviously when I can, and that hasn't been possible for some time, but hopefully I'll be there in the next few months. Before we dig into the science that you're doing now, let's go back and maybe turn the clock back to Newcastle University, maybe even before that. What inspired you to become a biologist? Oh,
great question. Do you know what? I've never had a clear vision on what I wanted to do as a career. You know how some people are very much like, I want to be a doctor, or I want to be a pilot, or something like that. I've never known. So my sort of philosophy in life has always been to follow what I was interested in. And one thing that I've always been interested in fact, fascinated by, is the human body. And just how complex the human body is, and how it works, and how it's so intricately designed and perfect to make us tick. And that's something that I've just always been fascinated by. So that kind of led me down the route of biology and looking into a science career. And I ended up doing a degree in biomedical sciences. And even at that point, I still didn't really know what to do with a degree in biomedical science. And I just had a real passion to just keep learning and get more and more detail how the body worked. And at the end of that degree, you have an opportunity to go and work in a lab. Is like an end-of-year project. And I went and worked in a lab, and I actually really enjoyed it. And just setting up your own experiments and basically discovering and asking questions about things that nobody really knew the answer to, and it was your job to find out the answer. So that's kind of led me down the route of becoming a scientist. And I would never have thought I'd been a scientist. I would never have said that when I was younger. But I guess it is just my passion for the human body, how it all works. That's really led me down that path.
And your clear interest now in science and the biology as it applies to human longevity, and those things that perhaps we can do in our lives, lifestyle interventions that could help us live longer and healthier. Did that develop over time as you got deeper into the subject?
Yeah, that was something that took a while to get to, actually. So my original, I guess, my training after I'd been and done my degree. I then went on and did a master's, and my master's was in research. It was literally a master of research, how to conduct scientific experiments, how to ask the right questions, how to investigate things and analyze things and think critically. And then my PhD that I actually did was about drugs. It was about how, when you take a drug or a supplement or a molecule, how does it get from your mouth or your wherever you take it into your cells, and then actually gets into the part of the cell where it actually needs to work. And that actually led me down a career of drug development. So after I'd done my PhD, I left Newcastle University and I went and worked for a drugs company. And it was at that point that I was actually introduced to the field of aging. And that was because basically the drugs company I went and worked for had a very unique way of doing drug development. It was quite a forward-thinking company that did drug development in a way that made it way more efficient, and it considered the complexity of the body a lot more than a lot of large drugs companies do. So I was working on cancer and cancer therapies, and while I was working there, we were actually approached by someone that was quite a big name within the longevity field, who approached our company and said, have you ever thought of looking into aging drugs or drugs to slow aging? Because the way that you think about drug development and the way that you do it would be really suited to looking at drugs for aging. And that is the point where I suddenly was thrown into the aging world, as I was the person that was chosen to run that project. And I had quite a steep learning curve, because you think you know a lot about biology and then you move into a different area and it just opens up a whole new world of things that you hadn't even heard of. You become quite specialized when you do a PhD and almost blank out the rest of biology. And this opened it back up for me. And from that point on, I was, just thought actually aging is the thing we should all be going after. That's what we should be researching.
And at that point, when it was suggested to you that perhaps aging and aging science could be the future, did you have to first of all figure out for yourself, what is aging?
Yes. So this is a question, actually. I always start a lot of my talks that I do with people, and I always say to them, first of all, we're going to talk about aging, but the first thing I want you to think about is, tell me what aging is, because it's a word and a term that everyone's familiar with, and everyone thinks they know what it means, but when they start trying to explain what it means, they find it really difficult. And it always comes back to, it's just this natural thing that happens and there's nothing you can do about it, and it's associated with bad things. And it's like, yeah, but what is it? Like, why is it happening? What's going on in your body? Like, what's causing it? It is a thing, but what is it? and for me, I think that I really had to consider that and start to think, well, yeah, what is it and why does it happen? And when you start looking into it, yeah, like I say, it opens up a whole new world and the way you think about the world, really.
And when we get into the subject and we talk about lifestyle interventions that could impact how we age and how well we age, and clearly we can talk about diet and exercise, which I think are very easy to get. And then we get into the area of supplementation and perhaps chemical interventions. And I think that's where people begin to put up a wall, because it's very confusing. There are so many options for people. How do you help us get through that barrier?
Yes, that's really interesting, because you tend to find that people are either pro-intervention in terms of drugs or they're against it. And I think a lot of people are against it just because they simply don't understand it. And for me, that's one of the things that I'm really passionate about. In fact, it's why I started my company, was to make that science and that explanation of how drugs and supplements and things like that may be able to help us more accessible to the layperson who actually hasn't considered what aging is and hasn't considered that there's a possibility that they could actually reverse it or age much better. So I think it's a lot about the education and really making people understand, first of all, what aging is, like in molecular terms. Even though people aren't scientists, you can still explain it. And then secondly, like why we age. And I think I always like to explain that in terms of evolution and get people to think about like how quickly our lifespan has suddenly become very long compared to what our ancestors' lifespan was. And people then seem to understand it in that way. And then finally, it's like, okay, now you've got that sort of background. Do you now think it's plausible that actually it's a good thing to try and slow aging? And if you could do it with a supplement or a drug, like, would you? And quite often people do then actually have a different opinion on it because they then fully understand it and feel more informed to be able to answer the question.
So you mentioned your company. Tell me more about it, what it's called, and how easy is it to set up a research company, a laboratory? And we'll continue this conversation in just a moment.
Hey, quick question for you. Are you someone who wants to be fit, healthy, and happy? And what if I told you could get your dream body by simply just listening to a podcast? I'm Josh.
And I'm KG, and we are the hosts of the Fit, Healthy, and Happy podcast.
Listen, we get it. Fitness isn't easy. Carbs, no carbs.
Just stop, okay? It doesn't have to be that complicated. And that's why we made this podcast. We get straight to the facts so you can become your best you.
So the way to check us out is click the link in the show notes or search Fit, Healthy, and Happy podcast on any of the major podcast platforms. We'll see you soon.
Like this.
My company, Nuchido Laboratories, was founded about 3.5 years ago now. And the reason I did it was because I think I'd been very naive going into the world of drug development, thinking that it was going to help people. And, you know, it does help people, but I was very frustrated at how long it takes to get drugs to market and how expensive it is. And, you know, most people don't realize to get a single drug to market, it's usually around 10 to 15 years and costs hundreds of millions of pounds. So that's a really restrictive point, that things that you could be working on in the lab that have real breakthroughs in terms of the science aren't actually going to reach people for a long time after that. So that was one thing that was frustrating. The second thing was the amount of things that work, so like molecules that could be drugs or supplements or whatever, that actually work and have really good data behind them, but never make it to the light of day because drugs companies can't get a patent to protect them. So basically a patent is something that allows you to own that molecule and make money out of that molecule. And if a drugs company can't own the molecule, it's not worth their while investing hundreds of millions of pounds into it, developing it as a drug, if they then can't recoup that money by being the only company that can sell that drug when it goes to market. So for me, that created a bit of an ethical dilemma, because I was sitting there, you know, part of my job was going through lists of molecules and checking if we could actually use them, or whether other companies had patents on them, or whether there were molecules that were like natural ingredients that couldn't be patented and nobody could own them. And there was a lot of things that were actually natural molecules that weren't patentable, that actually worked better than the molecules that were took forward to become drugs, which in my head was absolutely crazy. I was like, there's things that people could be using now in supplements and topicals, things like that are safe. They've got good data, but drugs companies don't want to know. So the whole mission behind founding Nuchido was actually, can we turn this all on its head? And can we set up a company that does all the same science that a drug development company does, so has all that expertise in how to find molecules that actually do something to the body and knows how to test them? But instead of taking forward the molecules that could become drugs, let's take forward the molecules that can be supplements, they can be topicals, they can be things that we can get to consumers within months and years rather than tens of years. So that is exactly what we do. Our mission is to basically translate this science into consumer products that are accessible to people now, so that they can start understanding and benefiting from the science right now.
And where did the name come from, Nuchido?
So it's it's Japanese. So it loosely translates to the path to long life. So there's an island in Japan, Okinawa, very famous for where people live till great age. There were a lot of centenarians and even super centenarians that lived there. And they have a saying, which is Nuchido, which is food is the path to long life. So obviously we're not selling food, so we sort of shifted it a little bit to make it mean the path to long life, and that's exactly where it came from.
And we'll return to my conversation with Nichola in less than a minute. You're listening to the Live Long and Master Aging podcast. This episode is brought to you by AgeUp, a new product that helps fill in the financial gaps that are often created once you've mastered aging and achieved an exceptionally long life. Small monthly payments to AgeUp stack over time to create a secure income stream for your 90s and beyond. Contributions to AgeUp are shielded from market swings, and once payouts begin at the age of 91 or above, they're guaranteed to last for life. AgeUp is backed by MassMutual and sold by Haven Life Insurance Agency. You can find out more at age-up.com. That's age-up.com. We're talking to Dr. Nichola Conlon, molecular biologist and founder of the Research and Development Laboratory with the name of Nuchido in the northeast of England. Nichola, let's talk. I mentioned in the introduction NAD, and this is a topic that we have delved into before on this podcast, but maybe you can explain once again why it is so important to us.
Yes, of course. So NAD, what is NAD? The million-dollar question. NAD is basically, it's a natural molecule that's found in every single cell in our body. And it's so important that if we didn't have it in our cells, if it all disappeared for some reason, we'd literally be dead in 30 seconds. And that's because of the critical role it plays in about over 500 different reactions in the cell. So I like to think of NAD in a much more simpler way, in that it does two really important things. So the first one that it does is it's very important in our energy production. So it's critical in getting the energy out of the food that we eat and turning it into the energy that our cells need to perform all their functions. Basically anything that they need to do, it requires energy, and NAD helps to get this energy out of our food and into the form of ATP, which is what the cells actually use as their energy currency. So that's the first point. The second thing is, and this is the thing that's more links it to aging, is that NAD is absolutely vital for acting as a signaling molecule in the cell. And what I mean by a signaling molecule is basically something that helps to switch on and off different processes in the cell. So what NAD does is it switches on and off lots of different maintenance and repair processes in the cell. So essentially, when you've got high NAD, what it does is it sends a signal to lots of processes in the cell to say, okay, keep our DNA repair switched on, keep any recycling in the cell going on, so we're getting rid of any junk proteins or anything that's damaged, and basically keep the cell in really good condition so it's well maintained and it's well repaired. So that's what happens when there's high NAD. Now, when NAD becomes low, all of that gets switched off. So your maintenance pathways get turned down, your repair pathways get turned down, all those different things that are keeping your cell in good shape actually get turned down. So those are the two really important things to remember. And the reason that NAD is actually implicated in aging is because our NAD levels decline with age. So when we're young, we've got really high levels of NAD, but as we get older, they get lower and lower and lower. And this is actually quite an exponential decline. So just to put it into perspective, when we are born, we have really high levels, and by age 20, we've almost lost half of our NAD. So NAD decreases by about 50% every 20 years. So that's quite a lot. And when this NAD declines, first of all, it's going to impact your energy because NAD is critical for energy production. And secondly, it's going to impact your repair in your cell because the levels are low. So that signal is not there to keep your to keep your maintenance and repair pathways switched on. So you get cellular damage. And ultimately that cellular damage results in the signs and symptoms that we call aging.
So what you're essentially doing is working on products to boost NAD levels, and especially important, as you say, for older people.
Yes, absolutely. So Ever since it was found that NAD declines, there's been a lot of companies that have been trying to boost NAD in people. So, providing supplements that are called NAD boosters to try and elevate NAD in people, because it's been demonstrated that if you can boost your NAD back up, it can have a huge amount of benefit, especially in terms of how well you age. So everything from increased neuronal function to reducing muscle wastage and loss as you get older, to regenerating stem cells, to improving insulin tolerance and less insulin resistance, improving cardiovascular function. The list goes on, and it's not surprising because NAD is in every cell in your body. It almost sounds too good to be true that this one thing could do everything, but it does because it's so important to health.
Presumably, though, we could look at the decline of NAD levels as a natural process as we get older. So one alarm bell in my mind, and perhaps the alarm bell in the minds of people without a scientific knowledge of exactly what's happening, is, can we be, therefore, artificially boosting our NAD levels? And could there be any negative consequences as we get older? Perhaps as we're older, we don't need as much.
Yes, and I think this is where I always go back to my why do we age question. So I always say that a lot of things don't make sense in aging unless you look at them in terms of evolution. So we as a species have evolved to live and be designed to live till we're about 30 or 40. That's kind of our optimal. And a couple of 100 years ago, we were really lucky if we made it to 50. It would be unheard of, really, to live really a long age. And that's because we didn't have proper sanitation, we didn't have proper healthcare. And we essentially, we lived young, died young. And that was completely normal. And that is what our evolution has made us good at being. It's made us good at being young, but not good at being old, because why would evolution develop systems in the body that were selected for being old when we never actually really reached old, or what we consider old, in the natural world, because we would have died of a tooth abscess or in childbirth, or if we're an animal, by a predator or something like that. So
and presumably evolution wants us to get to an age where we reproduce and pass on our genes, and then we have no use.
Exactly. The disposable soma theory, which basically means our body is a shell that carries our genetics. It passes it on to our offspring, and then our body becomes useless, which sounds pretty grim, but yes, it's pretty harsh, that's evolution. And so bearing that in mind, so we have developed all of these amazing repair systems that work terribly good when we're young, which means that it keeps our bodies in really, really good health while we're young. But the problem is they're often very energy draining, and they're often using up a lot of resources, which when we were only living till age 40, it didn't matter, because we never kind of grew old enough to have the negative consequence of depleting all those the resources or using these really energy-rich repair systems. But now that we are living longer, what we're starting to see is this effect. So using NAD as an example, when you're young, your NAD is continually getting recycled, so you're keeping these NAD levels really high. As you get older, what happens is all these other things are going crazy in the body, because the body's not linear or one thing happening. There's multiple things going on. So what happens is there's all these other things going wrong, which then also start wasting NAD, and then you get these vicious cycles where things that were actually really good at fixing you when you were young actually start causing problems as you get older. And they actually themselves cause this cascade effect of it starts depleting NAD, and then you get more damage, and then that leads to the first thing that started it, and you kind of go around in circles. So people say, well, is NAD depletion like a natural thing that's supposed to happen? And nothing in aging is supposed to happen. It happens because we're living longer than our body was designed to. So it's a design fault, if anything.
Or you could say that maybe we're living longer because science has developed in so many other areas. Imagine all the inoculations that we have as a child that help us perhaps get through early years and the rest of our lives. There's the flu jab, there's the COVID-19 jab that presumably we're all going to be taking, well, at least for the next year and maybe forever. We don't know yet.
Exactly. Exactly.
Science has developed to keep us alive on many fronts.
Exactly that. And that change, those scientific advancements have happened so fast at a rate that evolution could never keep up to. So we are very good at being young, but we are not designed to be good at being old. And that's why you see lots of different things going wrong as you're old, because they were never, there was nothing selected to make us good at dealing with that. In fact, a lot of the things that keep us healthy when we're young can actually have negative consequences as we get older. And back to NAD, basically with NAD, what you find is that it's decreasing as you get old, and people will say, well, is it not just meant to decrease? Is there a reason it's decreasing? And is it not good, that it gets lower as you get older? But everything that is associated with NAD, for example, cancer. So your risk of cancer exponentially increases as you get older. And at the same time, your NAD levels are exponentially declining. So they're inversely correlated. And that's no shock, because NAD is incredibly important in repairing DNA damage. And when you get DNA damage, that is the biggest cause of cancer. So your NAD is dropping, your risk of cancer is actually going up. Your body is really used to having high levels of NAD. That's how it's born. That's how it's got throughout your youth, as far as evolution's concerned. It needs those high NAD levels because it's so critical in the cell function. So everything associated with high NAD is generally good.
You mentioned the slow process in terms of developing drugs, I suppose from the theory, from the idea to the laboratory tests to the clinical trials to actually getting it on the market. So where are you right now in terms of developing a product to boost NAD?
So we actually have a product that's now on the market. So we did a soft launch a year ago where we kind of went to some conferences and put it out there in beta mode, basically, to people that are into this world of NAD boosting to kind of test the water. We're now doing a full launch, especially in the US, where we've got our full website launch. We've got a clinic and affiliate partnership launched to work with a lot of NAD clinics. Yeah, we've been getting it out there and seeing what people think of it. So we've done all the testing on it. We've done human clinical trials on it. We have data to show that our product boosts NAD better than some of the older generation NAD boosters that people are more familiar with. And that's because we have took a completely approach to some of the other NAD supplements out there in the way we actually boost NAD.
So they're not all the same.
No.
And you refer, and that gets complicated. You refer to the people who are into this kind of thing.
Yes.
And I know exactly who you're talking about. And some of those people recently have said to me that they are using NMN, nicotinamide mononucleotide supplementation, which is similar. It's close to what you're talking about, but a little different.
Yes, exactly. So maybe it helps if I explain the different ways in which people are trying to boost their NAD levels, because then it makes the way we do it make sense, and it exemplifies how our approach is more superior. So basically, a lot of people are taking NMN, which is what you've just referred to, or they're taking another supplement called NR. They just stand for nicotinamide riboside and nicotinamide mononucleotide. So those two ingredients are what we would refer to as NAD precursors. And all this means is that they are the raw material that the body actually uses to make NAD. So the idea being that you have a decline in NAD in your body. So why don't you give the body more of the raw materials that it uses to make NAD, and hopefully the body will turn it into NAD, and then your NAD levels will go up, which does happen to a certain extent. So you do get a small NAD boost with these types of products taking this approach. The problem is that over the last sort of 4 years, there's been advancements in the science which now show that the reason that your NAD is declining is not because your body has a lack of this raw material coming in to make NAD. Your NAD levels are actually declining because they are the systems that actually convert these raw materials into the NAD are failing within the cell. So you've got enzymes within the cell that actually make these raw materials into the NAD. And that's one reason why your NAD declines. The other reason is that as you get older, your cells actually start wasting NAD. So they've got all these different proteins and inflammatory proteins that start being upregulated in your cells, and they actually chew up NAD like there's no tomorrow for no particular reason other than it's getting wasted. So if you imagine, I like to get people to think of the cell as a factory, okay? So if you've got this cell factory and it's making NAD and the NAD production's gone down, would you say that it's a good idea to just order more raw material into the factory if you know that the reason production's gone down is because the machines are broken, so they're the enzymes, and actually because the factory is being really wasteful because the pipes are leaking? Would it be a good idea just to say, well, we'll just order some more raw material and hopefully the production will go up?
And what I generally say at this point in a conversation that's getting pretty technical is that clearly this is fascinating. There are different routes to achieving perhaps the same thing. And it can be confusing to people. And the first thing I always emphasize is that if you are interested in going in this direction, perhaps if you have health issues and you feel that some sort of external supplementation or intervention in your diet is necessary, the first thing you do is talk to your doctor. And I just try to really share ideas and spread ideas with this podcast. But we're all individual. Our bodies are different. We all respond in different ways to interventions, whether it's exercise or diet, whether it's the food we eat for dinner. And that, as doctors often say, it's do no harm. It's safety first.
Absolutely.
And so I always say to people, talk to your doctor, get some professional advice. And the other thing I think that's increasingly confusing to people is that we've just implied that there are several products perhaps claiming to ultimately achieve the same thing. And this is just one small part of our bodily function, our metabolism. There are other supplements to help us and help our bodies in other ways. And the confusion can sometimes lie in, well, where do I stop with this supplementation? I could take this and I could take this and I could take this. And it gets mighty difficult for people to decide, doesn't it?
Yeah, absolutely it does. And I think, you've just hit the nail on the head there. Even within the NAD boosting supplement arena, there are multiple ways and they're not straightforward. And it's hard for people to understand and cut through what's nonsense and what actually works and what has good science behind it and what's made to good standards. And there's all sorts of things that you've got to consider. And, that for me, that's a really important thing. It's really trying to explain to people in a way that they can understand it and they can make informed choices to choose what's the best path for their health, or what supplements they want to take, or what regimes they want to embark on, or interventions that they want to try. But as a goal at Nuchido, it's about trying to bring things out that do have good science behind them and make people understand why it's a better way of doing something if there are other ways. And so they can understand, right, this is how, for example, this is how the NR supplements work, or the NMN supplements work. They're the raw material. They're not fixing the NAD problem in your cell. Whereas with our supplement, Nuchido Time, ours is like, we explain it in a way that this is actually fixing the underlying problems in the cell. So you're actually restoring your cell's own capacity to make its own NAD again, rather than just trying to chuck in more raw material to the cell factory. So yeah, it's about the education, and that's going to be such a major part moving forward within the longevity community, to make sure that we educate and really talk a lot about what's going on with the science and how it can benefit people, and the best way to approach it, because it can be a sensitive subject for some people.
Yeah, I agree. It is fascinating, though. I want to just change tack as we bring this to a close. I'm curious, as a woman scientist in what can sometimes be a very male-dominated world, how has your journey been so far?
That's an interesting one. Well, I would not say I've had the easiest time. So I've got a bit of let's say I didn't do things the easy way. So I had a baby when I was doing my master's. And, I was actually actively discouraged from doing a PhD after that. A lot of people saying, you can't have a child and do a PhD, and you've got to, if you want to be a scientist, you literally have to give your life to it and accept that you can't have a family till you're older, and basically devote your life and marry a science career. And yeah, I just sort of said, well, no, I'm going to do both things. And I can't say it was that easy having a newborn child and doing a PhD, but I managed to do it. And, I've made a successful career out of it. And it has been hard, but I always like to use myself as an example that it is actually possible to do that. I'd say I am usually outnumbered by men in the science field. It's not as bad as it used to be, but then I've sort of took another career swerve, which is now, I'm essentially an entrepreneur. I've started a company, which again is another male-dominant world. And I know I have had instances where it's quite funny with myself and the co-founder of the company, who is male and older than me. We've gone into a meeting, and the person we've gone to meet will say, "Oh, great, Nicola, you've brought your boss today," which can be quite embarrassing.
Yes, you just try not to respond instantly to that.
Yeah. So I don't know. I guess I'm quite a tough cookie, and I don't let things bother me. But I think some of the things that I've seen and heard and had said to me could probably damage some people that aren't as sort of thick-skinned as me. So it is still a problem, unfortunately, that there is a bit of inequality there, but it's definitely getting better.
Well, that's good to hear. And you're doing good work, which is clearly one of the main things. I'm just curious, as we close, and I always ask this question to people in your position, from everything that you know and understand today about your health and the work that you're doing, what kind of lifestyle interventions do you use with yourself to promote your own health and well-being and hopefully longevity as well? And in terms of longevity, do you have a vision in sight? Do you have aspirations?
So the first question, what do I do? So I think I do a lot of lifestyle interventions, definitely diet, exercise, fasting, things like that, because I think, although I am a company selling supplements, which I do take, I think you cannot underestimate the how good some of the really simple and free things are. And I always try and drill that home to people. The other thing that I am massively, I really advocate is people getting their blood done. Like understanding what's normal for your body. And it's something you touched on earlier about everyone's an individual. And it's so accessible now. There's lots of companies that do it where you can get a finger prick blood test and you can monitor your blood every 6 months. It doesn't cost that much. And you can understand what is normal for your body, because what is normal for you, sometimes doesn't fit in with what national guidelines are or what's normal for the average of the whole of the UK, for example. So I think that's such a powerful thing, to be able to monitor your own biomarkers, your own health, because you can pick up on things that are maybe slightly going off way before it ever becomes a problem. And I think this is especially critical, being from the UK, where we've got the NHS and we're so reliant on sick care rather than healthcare, where we're only, going to a doctor or whatever when we're already sick and we've already got symptoms. Being able to pick up on things before that is so important, because it's trying to protect what you have already when it comes to anti-aging. So that's something I'm massive on, tracking your own body. And then for the second question of what are my aspirations, sky's the limit. Like I see so many amazing things all the time, breakthroughs all the time, and the things that can happen with mammals and cells, just some of the processes where literal rejuvenation has been proven. 10 years ago, a lot of people, even within this field, would have been skeptical that you could literally turn back the clock. Now, you will not find a single person that works in the field of biogerontology, which is the study of aging, that does not believe that rejuvenation is possible. It absolutely is possible. And I do believe that we'll get to a point where we can almost preserve what we have and preserve our mind and our body, and just continue living a really good, healthy life.
You're almost sounding like an immortalist. There are individuals who put themselves into that category and talk about quite literally living forever. And certainly I don't, and I'm not in that area. And I talk about health span of just extending our healthy lives as long as possible. But maybe in 100 years' time, 1,000 years' time, we can talk about living forever. But I don't think we're there yet, are we?
No, I don't think so. And I still don't know what my opinion is of uploading my brain to the cloud and not living in my body. Like right. Yeah, I know a lot of people do believe in that. And I don't know what I feel about that. But I think the way I view it is that things are moving so fast. Look at COVID as an example, right? A year ago, if we'd have said that it would be completely normal to walk around with a mask on and to isolate in your house, everyone would have gone, that's absolutely ridiculous. And now we're all doing it. Yeah. So we might be sitting here going, oh, in 20 years, we'll all be saying we can live forever. Well, that's ridiculous. But who knows? Because things are moving so fast. Who knows? So I would never say never. Yeah. And it's healthspan. I would not, part of my drive for doing this as well is seeing my grandparents suffer like in a care home in an awful state. I do not want to end up like that. I don't want my family to end up like that. And that's why I founded the company, so we can start doing things now to improve our healthspan and not wait until the governments and the rulers of the world decide it's a good idea to have healthspan drugs.
Yeah, no, I totally agree with you on that point. Nichola, this has been a fascinating conversation. Best of luck with your future work. Really good to talk to you. Thank you.
Thank you. Lovely to talk to you, Peter.
And if you'd like to dig a little deeper into Nichola's work, I'll put some links into the show notes for this episode. You'll find them at our website, Live Long and Master Aging. We use the acronym LLAMA, so it's LLAMA podcast.com. And if you enjoy what we do, you can review us, you can rate us at Apple Podcasts. The Llama Podcast is a HealthSpan media production. You can follow me in social media at Peter Bowes. It's always good to hear from you. Many thanks for listening. Health optimization is what this podcast is all about, and that means taking care of our mitochondria, the energy centres of our cells. Physical strength, avoiding frailty is key, and that's why the science behind urolithin A and the work of Timeline Nutrition is so interesting. You can find out more and get a discount code at our website and in the show notes for this episode.